All right, here we go. So, we're past this. We are going to finish our 6.4 notes. Yesterday we stopped at, where we stop at the table. Okay. So yesterday we stopped at the tables. Now, the reason why this table is important, because 30, 45, and 60 all fall in quadrant 1, right? And as we start filling in our unit circle, we're going to learn that quadrant 1 is how you do everything. So if you can do quadrant 1, then you can do the rest of the circle. Does that make sense? Yeah. All right. Oh my gosh, where's my pen go? Okay. So here we stop. We're on 60. And we talked about 30 and 60. What kind of what's their relationship called? What are they called?
I got the complementary.
Oh, they're complementary angles, which means that they are co-function trig. Okay, which means that the sine of 30 is the cosine for 60, and the cosine of 30 is the sine for 60. Do you remember that yesterday? Okay, so when I fill this in, since I know that sine is 1/2 for 30, that means that cosine for 60 is also going to be 1/2. Since the cosine of 30 is square root of 3 over 2, then the sine of 60 is going to be square root of 3 over 2. Okay, their tangents are reciprocal of each other. So the reciprocal of square root of 3 over 3 is 3 over the square root of 3. Is that allowed?
No.
No. What do we have to do?
Multiply it by the radical.
There we go. We have to multiply by the radical. We have to rationalize, right? When we rationalize, what are we left with?
3 square root of 3 over 3.
3 square root of 3 over 3. Perfect. So therefore, the tan of 60 is square root of 3. Okay. These are the heart of the unit circle. If you can tell yourself in your head these 9, you can do the entire circle. Okay. You can do all of your special angles. All right. That's what this is for. All right. So let's test it out. Yeah. Sine 30. So really quick, I want you to cover the top and try to think about it. So covering the top with your hand, don't cheat, challenge yourself. What is the sine of 30?
No.
Is she right or wrong?
Right.
Good job. All right. Okay. Tan of pi over 3. What is pi over 3?
30, right?
Pi over 3 is 60.
Yeah.
So we're looking for the tan of 60. Hint, we just did it.
Square root of 3.
There we go. Square root of 3. All right. Going back to earlier yesterday, cosine of pi. Ooh, cosine of pi.
That's the cosine of 180, right?
Mm-hmm. Remember, cosine is your x, right? So what is the cosine of pi? What's the x at pi? What kind of 1? It's a -1. Okay. Cosine of pi over 4. What is pi over 4? 45. What is the cosine of 45? Square root of 2 over 2. Remember, that's your right triangle with the 1, 1, square root of 2. Okay. What is the secant of pi over 6?
That's 30, right?
So pi over 6 is 30. Secant is the opposite of what? The reciprocal of who? Cosine. So you're looking for the reciprocal of your x. So what was the cosine of pi over 6? Oh, yeah.
It's a big fat boy.
What's the cosine of pi over 6? Square root of 3 over 2.
Oh.
So then what is the secant?
2 square root of 3 over 3.
There you go, because you have to rationalize, right? All right, what about cotangent of 90?
1. Found that.
Cotangent means x over y. What is the x at 90? 0. What is the y at 90? 1. So what is it? 0, because it's okay in the numerator, right?
90.
Right on
90.
top.
I knew that. I was testing on.
Okay. Did we pass?
They did.
All
Yep.
right, so now let's fill in the entire unit circle. All right, the main thing that we're going to start off remembering is that we're not going to really focus on what's positive, but remember everything. So all 6 are positive here. So all 6 trig values are positive. That's because our X and our Y are positive. Okay. In this quadrant, in quadrant 2, the only thing that's positive is sine and cosecant. That's because here our X's are negative and our Y's are positive.
Is this how our, test gonna be? Like we have to write that as well?
No, this is just to help you remember.
Oh,
Okay, here in quadrant 3, only tan and cotangent are positive. And that's because you have a negative X and a negative Y. A negative divided by a negative makes a positive. In quadrant 4, only thing that's positive is going to be cosine and secant. And that's because you have positive and a negative. So remember, all students take calculus. All are positive in quadrant 1. Sine and cosecant are positive in quadrant 2. Tan and cotangent are positive in quadrant 3. And cosine and secant are positive in quadrant 4. All students take calculus. The 8 in the beginning. Okay. So just to help away, all students take calculus. Telling you, remind you what's positive where. Okay. The other thing that we need to take from our notes is that our cosine, comma, our sine means that it's our X, comma, our Y. The cosine and the sine are the X coordinates of where this would lie on a unit circle. So a circle with a radius of 1. All right. I'm going to tell you how I learned and how I memorized unit circle, but you're your own human, so you're going to figure out your own, okay? First, I start off by doing my degrees. So I first go through and put in degrees because degrees are the easiest thing for me to put in. So I'm going to go through, put in my degrees, 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, and 330. And last but not least, 360. Okay. What helps me is that I realize that there's a pattern on my way around. I paid attention to the fact how far my quadrant angles are from the axes that they're close to. And then I realized that in between each quadrant angle is 15 degrees. So that helped me remember where those angles are. Okay. Does that make sense? Next, I go through and do my radians. With my radians, I start with pi over 6 and I reduce as I go around. Does that make sense? All right, so we have 1 pi over 6, 2 pi over 6, which is pi over 3, 3 pi over 6, which is pi over 2, 4 pi over 6, which is 2 pi over 3, 5 pi over 6, 6 pi over 6, which is pi, 7 pi over 6, 8 pi over 6, which is going to be 4 pi over 3, 9 pi over 6, which is going to be 3 pi over 2, 10 pi over 6, which is going to be 5 pi over 3, and 11 pi over 6, and then 12 pi over 6, which is going to be 2 pi. So by going around and counting by 6s, I end up filling in pretty much all of my radians.
Oh, that's a 5. Okay.
Yes, 5 pi over 3.
I was like, why does it go from 8 pi over 6 to 5?
Okay. What are your questions about counting by 6s? Now, if you're not strong at reducing fractions as I am, well, you may have to write that reduced fraction on the side and reduce it. Yeah, you can. So if you had to write on the side 3 pi over 6 and then make it pi over 2, that's fine. If you had to write, does that make sense? 4 pi over 6 and make it 2 pi over 3, that's fine. Okay, the last ratings I go through and put in are my pi over 4. So I have 0, pi over 4, so that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. And last but not least, 8 pi over 4. And now I have filled in my degrees and my radians. Okay. Questions, comments, concerns so far? After that, I then put in the ordered pairs for my quadrantal angles. Again, just because this is the way I do it, do you have to do it this way? No, I'm just showing you how it helped me, okay? I start off with my quadrantals. Remember, this is a unit circle, so this is 1 unit from the center. This is 0, 1 from the center. This is -1 from the center. And this guy is 0, -1 from the center. So my quadrantals are put in. After I put in my quadrantals, I then put in my ordered pairs of quadrant 1. The reason being is because if I can do quadrant 1, I can do all the other quadrants. Okay, so ordered pairs for quadrant 1. 30, I'm asking what is the cosine of 30 and what is the sine of 30? What is the cosine of 30?
Cosine is square root of 3 over 2.
Square root of 3 over 2. What is the sine of 30?
1/2.
1/2. What is the cosine of 45?
Square root of 2 over 2.
And what is the sine of 45?
Square root of 2 over 2.
Okay. What is the cosine of 60? What is the sine of 60? Okay. Once I have the quadrant 1 in, I can just use the rule of reference angles. And the rule of reference angle is that the ordered pairs are the same, just their sign changes. Because it's where they're placed. So when I follow my 30s, so all angles that are 30-degree reference, they're going to have the same ordered pairs. So all the angles that are 30-degree reference are going to have the same ordered pair. So that tells me I can write square root of 3 over 2. Where'd it go? I don't know why I did that. Zoom back in on there. So I can write, So I can write square root of 3 over 2 and 1/2. But I have to be conscious of what are the signs here. The signs in quadrant 4 have to be positive and negative. I can come over here and write square root of 3 over 2 and 1/2. I have to be conscious of the signs. The signs here have to be negative and negative. In quadrant 2, I can write square root of 3 over 2 and 1/2, but I have to be mindful that my x has to be negative. I'm going to do the same thing. So now I'm going to do 45. So I'm going to highlight all the angles that have a reference angle of 45. Because all those angles are going to have the same ordered pairs, except different signs. Okay, so in quadrant 2, I have square root of 2 over 2, but x is going to be negative, y is going to be positive. Quadrant 3, I have square root of 2 over 2, square root of 2 over 2, and they both are negative. And quadrant 4, I have square root of 2 over 2 and negative square root of 2 over 2. The last of my reference angle are my 60-degree. So all angles that are 60 degrees in reference to the x-axis are going to have the same ordered pairs. I just have to pay attention to their signs. Don't look at it. They're straight lines. Okay, so here we have negative 1/2 and positive square root of 3 over 2. Here we have -1/2 and negative square root of 3 over 2. Here we have positive 1/2 and negative square root of 3 over 2. And ta-da! Our entire circle is filled in. With this circle alone, you can find all 6 trig values of all of the angles on here just by using this circle.
Can you zoom her in?
Yes, I can.
Really good experience. A little bit more.
What?
Let's make our way up and down.
Okay, now the reason being is that now that I'm on the unit circle, we know that the radius is 1, right? And so because the radius is 1, all we're focusing on is just your X and your Y. What are the trig ratios in reference to X and Y? Does that make sense? Okay, so at the bottom, you should have enough room. We're gonna write everything in terms of X and Y only. And the reason being, again, is because R equals what? 1. It's a unit circle, so R equals uno. Okay, so at the bottom, we're gonna write all of our ratios. So sine of an angle is just gonna equal the Y coordinate. Cosine of an angle is gonna equal your X coordinate. Tan of an angle is gonna equal your Y divided by your X, which means that you're taking Y and multiplying it by the reciprocal of X. Because when you divide fractions, you keep, change, flip, right? We keep the numerator, change to multiplication, and multiply by the reciprocal. All right, they're reciprocals. So sine is cosecant theta, which is going to be 1 over Y. Whoa, pin. 1 over Y. Cosine is going to be secant theta, which equals 1 over X. And tan theta, which is going to be cotangent theta, equals X over Y, which means I'm taking the X and multiplying by the reciprocal of Y. There's no R in this situation because it's all on the unit circle and R equals what? 1. Got it?
Can you go back up?
Go back up. Well, hold on. What are you missing?
My outside,
All of the ordered pairs?
not all of them, most of them. So we're on the table. What's in the table?
Okay. All right. So for your bingo, you're going to be using your unit circle. Okay. You're going to be using your unit circle and the ratios that we just wrote at the bottom. All right. Yes.
Sure.
All right. How do we feel? What are your questions, comments, concerns? What are you hesitant about? Okay. For example, let's just do a trial. Are we ready? Using your unit circle, what is the cosine of 300? Using your unit circle, what is the cosine of 300? 1/2. Good job. Why is it 1/2?
Oh,
There.
there.
Because your X is your cosine, right? Yes, it's 1/2 because the X coordinate is your cosine. Okay. What is the sine of pi over 2?
It's 0. That's 1.
Why is it 1?
Because sine is Y.
Sine is your Y. Does it make sense?
I'm not fast enough for this.
Okay. Okay, here we go. What about the tangent of 180? Tangent of 180.
Undefined.
Why is it undefined?
Because 0 is in the numerator.
0 is where?
Sorry, denominator.
Denominator is undefined because 0 is in the denominator.
Wait, did you say tan or cotan? Because if it's tan,
yeah,
then what-
tan, sorry, it should be 0.
Yeah.
Yes, sorry.
0.
Yes, 0, because your 0 is in the numerator. Okay, but that's how you use the unit circle to find those values. Okay, so as long as you know those ratios, then you can manipulate it. Okay. All right. All right, so I'm gonna put up for the bingo, I'm gonna put up a list of values that you can put on your bingo board, okay? There are only 16 squares, but there are 25. There's 25, there's 20 or 25. There's 20 possibilities. Right now, choose your free spot. You can put your free spot anywhere you want it.
It's not even set there.
Nope.